Alright guys, this next problem we're going to work on is similar to exercise number 6 on your sum of a finite geometric series worksheet. So we have a word problem. Tyler puts 10 pennies in his piggy bank in January, 30 pennies in February, 90 pennies in March, and so on. How much money will Tyler have at the end of the year? So we're going to find the sum of this geometric series, and we know that the things we need for that are going to be A1 we want to find, N we want to find, and R we want to find. So now we know N1, it's going to be 0.1 for 10 cents. You could also write this as 10 and divide out your answer by 100 to figure out dollars at the end, but I think it's easier to just do 0.1 for 10 pennies, which is 0.1 of a dollar, 10%. And then to find our N, we know that he deposits once a month for 1 year. So that's pretty easy. That just is going to be 12 times a year, 12 months. I hope you guys know that. To find our R, I'm going to start by writing out just a little bit of our series, and then we can look at what our common ratio is. So we have 0.1, next time is 0.3, next time is 0.9, ... So we can see here that every time we're going to be multiplying by 3. So that's going to be our common ratio is 3. Now from here, super easy. It just turns into a calculator problem. So we have to look back and remember our sum of a geometric series equation. So we're going to have S of 12, our sum of the 12 terms, and that equals, first thing, we have a fraction. On top, we have our first term, so 0.1, and then 1 minus our common ratio, which is 3, to our number of terms, which is going to be 12. And then on top of that, or on the bottom of that, we're going to have 1 minus our first term, which is, our common ratio, which is 3. So now we can just throw that into our calculator. I'm going to show you all of the steps because we like to do that. I have 0.1, and then 1 minus 3 to the 12 is negative 531,440. So you're probably going to get a big number there, over negative 2. And that is going to be equal to 26572. So that's $26,000, 572. That is a lot of money. And there's your answer.